Hello guys, welcome once more to class online. I am Tutor Dami, and in this edition we shall be looking at Jamb Physics 2014 question number 6 to number 10, and we shall be having a nice time. It is promising to be very interesting. Now let's check out. Don't forget that if you learn something from this video, you will click on like button. You can click on like button. We have lots of content to send to you that will better help you destroy Jamb Physics. Let's go now to number 6. Question number 6 says, from the diagram above, the region of zero acceleration is what? Now, do you know what zero acceleration means on this graph? Now, look at this. This is the beginning. It was at rest at M. It moved up, accelerating up. You know, when something accelerates, it's like that thing was resting and it started running. So it ran up. Then it increased in speed up. Then it got to this place and stopped. Then it went straight. It was no more running faster. It was running at the same speed. So it is not accelerating at this point. It is at zero acceleration. And that is what we call constant speed or constant velocity. See, it is moving constantly. Then when it got to S, it began to accelerate again faster and faster. It came to P, then it started going down and getting slower and slower and slower until it stopped. So this is the place where it did not accelerate, or it has zero acceleration, where it was not running faster than it should, is at the constant velocity point. That's at the constant place here. It is no more going up or down. It is just at the same level, constant. That is zero acceleration or constant. And the answer is just N to S. N to S. It happened at NS, and that is the simple answer to the simple question. The car accelerates uniformly from rest 3 meters per second square. Its velocity after traveling a distance of 24 meters is what? Now this is a simple motion question, right? Now this is a linear motion question, but it's accelerated uniformly from rest. The word rest means that it was resting before, and that means that the U initial velocity is zero. Now what formula has acceleration, velocity, distance in it among the equations of motion? Which equation of motion has all of them? You know, these are the 4 equations of motion. U equals V equals U plus AT, S equals UT plus 1 over 2 AT square, V square equals U square plus 2AS, and S equals U plus V over 2T, right? These are the 4 equations of motion, where my V is my final velocity, my U is my initial velocity, my A was acceleration, and my T is time, and my S is distance, right? Now, in the question I was giving, when it said rest, it means that the initial velocity or the speed of the car at the beginning was zero. That's the meaning of rest. It was not moving. It was at rest. That means the initial velocity is zero. So you must notice, in any physics question when they say rest, rest means that U is zero. Then the acceleration at the beginning is 3 meters per second square, right? Then I'm to find the final velocity, which is V. Then I have my distance is 24 meters. Now, which of these equations of motion has U, A, V, and S? Of course, the one with that is equation 3. V square equals U square plus 2AS. And that is the one to use. V square equals U square plus 2AS. Why is it this one? Because it has V, it has U, it has S, it has A. It has everything that the question needs. Now, if I have used the first one, I'll have problem because I don't have T. T was not given in the question. Okay? And any of them, every one can't work because they all have T. So, but the only one that has this parameter that I need is equation 3. And therefore, using V square equals U square plus 2AS. Okay? I'm to find my V, right? So, what my U square is 0. Then my 2 is 2, that's my acceleration is 3, and my S is 24. So my 0 square is 0, 2 times 3 is 6, 6 times 24 is 144. V square is 144. Then the square will come here and become root 144, and that is 12 meters per second. And that is the answer to that question. It's simply 12 meters per second. And that brings us to the answer, making option D the correct answer to the question. Number 8. Calculate the escape velocity of a satellite. Learn from the Earth's surface if the radius of the Earth is 6.4 times 10 to the power 6 meter. And G is that's acceleration due to gravity is 10 meters per second square. You know, escape velocity is used by a rocket when they are going out of the earth. The escape velocity is for escaping the earth's gravitational field. It is the speed at which a rocket must move in order to burst out from the earth. So if you must go out from this earth, there is a speed you must be moving, and that speed is called the escape velocity. If you are moving lower than that speed, you will not burst out from the earth, and that is just it. It will be difficult, and the rocket might even explode. So there is an escape velocity for planet Earth, and that is it. Now we are told to find that escape velocity in this case. This is the Earth radius, and this is g. Now, but you must know the formula for escape velocity is just v equals root 2gr. Don't forget, it is v. Anything escape velocity is root 2gr. Root 2gr. Where my 2 is 2, my g, that's my gravity, is 10, and my radius is 6.4 times 10 to the power 6. Okay. Now, if I do this, I'll be getting what? 2 times 10 is 20, and I have this 6.4 times 10 to the power 6. Okay. Then I'll have 20 times 6.4 is 128. Okay, times 10 to the power 6. Then the root of 128 is 11.3. The root of 10 raised to the power 6, you know, root can also be 1 over 2 in power form. So that means I just did 1 over 2 times 6, and that is 3. Or you can just put it directly, root 10 raised to the power 6, it will give you 10 raised to the power 3 as your answer. So I have 11.3 times 10 raised to the power 3, and then if I put it further, meter per seconds, right? And that's my answer. But I can put it also in kilometer, because 1,000 meters make 1 kilometer. So to make it into kilometer, just this 10 raised to the power 3 means 10 times 10 times 10, which is 1,000. So convert that 10 raised to the power 3 to kilo, because that's kilo. 1,000 meters make 1 kilometer. So that 10 raised to the power 3 is 1,000. Okay, so that will give me kilometer per second. So it made 11.3 kilometer per second, and that is my answer. 11.3 kilometer per second, and that is the escape velocity for this rocket, for this satellite, and that is the way it is. Number 9 now. Let's check out number 9 now. Question 9. An object of weight 80 kilograms on Earth is taken to a planet where the acceleration due to gravity is 1/3 of its value on Earth. The weight of the object on the planet is what? G is 10 meters per second square. Now, how can you find out? This is what to do. You know, weight have to do with acceleration due to gravity, right? But it was moved from Earth, where it has, and it was moved to a different planet. Okay, where there was gravity is 1/3 of the Earth. That means 1/3 lesser than the Earth. Okay, so this is what to do. The weight of the substance is, you know, naturally weight is mass times gravity. Mass times was acceleration due to gravity. So my weight is 80 times the acceleration due to gravity on that planet is the gravitational, the acceleration of the Earth, which is 10 over 3. You know, they say 1/3 of the Earth. Now, if I were to ask you, what is the acceleration due to gravity of the Earth? It's always 10, right? Now, but that of that planet is 1/3 of the Earth. That means 10 divided by 3. So now, on the planet, the mass is still 80, because mass doesn't change. Okay, so it's still mass is 80, and then the acceleration due to gravity is actually 10 over 3, and that will give me 800. That's 80 times 10 over 3, and that will give you 266 Newton, and that is the answer for that question. But if you look at the option, there is no 226 Newton there, and that was what I saw when I was going through it. Now, and after finding going through it carefully, I discovered that there's a mistake on the 80. It was a mistake on the 80. Instead of 80 kilograms, it should have been 8 kilograms. So if you put in 8, it should have been 8 kilograms times 10 over 3, and that will become 226.6 Newton, and that will be approximately 27 Newton, and that of course is in the option. The answer is 27 Newton. So I believe that the main mistake on the is a typographic error. It should not have been 80 kilograms, it should have been 8 kilograms. Okay, 8 kilograms, and this is how to go about solving it. Weight is always mass times gravity. Then the mass is what, 8, and the gravitational force is that of the Earth, that's 10 divided by 3, and that gave me 27 Newton as my answer for number 9. And that is it. Let's check out number 10 now. One of the conditions necessary for an object to be in equilibrium when acted upon by a number of parallel forces is that the vector sum of the forces is what? Now, anything equilibrium like these forces you see here, they all sum up to 0. Now that means for a force, now no, equilibrium means that the word equilibrium came from the word equal. The forces, if you add them up, they will be equals to 0. That means if you add up all the sum, the algebraic sum of all the forces that are at equilibrium will amount to 0. And that is just it. Now look at this force now. These are in equilibrium because they are all meeting at this point, right? So they are at equilibrium. But if you add this force and this one, it will amount to nothing. It will amount to 0. That means they are balanced. They are at equilibrium. And that's what it means to be in equilibrium. So the answer is just 0. The sum, the vector sum of the forces will be 0. It's like if there's an object and you are pulling it. If somebody's here, if this is equilibrium. If somebody's here, if Femi is here, and then Toby is here, and they are pulling a chair, okay, and they are pulling it equally, and the chair is not moving, the sum of all their forces, this one pulling it here and this one pulling it here, if they are not moving, they are said to be at equilibrium. And that reason is because the sum of their forces on the chair is 0. So that chair is just resting, like there is no force acting on, because the two forces cancel each other out, and therefore the total force is 0. So when the total force is 0 for any system, that system is said to be in equilibrium, and that is the meaning of equilibrium. Total force is 0. Like when I was small, we usually play one game called tug of war. We will pull. There's one rope that we pull. Some people will stay on this side, some will stay on the other side. Then we pull at a point, it will be balanced. If you pull and they pull, there will be no more movement. Everybody will just stand still, and the rope will just be like this. Like you can keep pulling. I'm not moving since you are all equal. So at that point, we are said to be at what? Equilibrium, because we are equal. The forces are equal. So if there's 5 force here and there's 5 Newton force here, if there are 2 5 Newton force here, if 1 5 Newton force is here and 1 5 Newton force is here, and we are pulling it with 5 Newton forces, the total force will be 0, because 5 minus 5 cancels each other out, and therefore that's 0 force. That means the rope is not moving, and that means the rope is in equilibrium. It is at equilibrium tension. So the answer is just 0 for anything equilibrium. The total force is 0, and that brings us to the end of the video. Don't forget that if you learned something from this video, click on the like button. We have more content to send you that will better help you understand physics. Until we see again, guys, take care of yourself and bye for now.